Hello everyone, my name is Abhishek and welcome back to my channel. In today's video, we will learn how to containerize a MERN stack application and deploy it in a Docker environment using Docker Compose. If you're not aware what is a MERN stack application, don't worry. In this video, I will also explain the MERN stack architecture. Why is it getting very popular? And I will also walk you through the source code of this MERN stack application. So you can watch this video till the end and you can learn what is a three-tier architecture application, what is MERN stack, how to write Docker files for a MERN stack application for different services, and how to deploy them using Docker Compose. So make sure you watch this video till the end. Now, before I get started, let me quickly walk you through this GitHub repository. There are two branches. One is the main branch. Second is the compose branch. So the main branch does not have anything like the Docker file, Docker compose. It's just the source code and steps how to run the application using npm without containers. So you can assume this particular branch is shared by the developer who has written this MERN stack application with basic instructions of how to run this application locally without Docker. And then I have created another branch called compose branch, which is going to be the outcome of today's video, where for this simple application, we will set up Docker files. So we will write Docker file for the front end, and similarly for the back end also we will write the Docker file, and we will run a database which is MongoDB as a container. I will create a common networking for all of these components so that they can communicate with each other, and we will also learn how to write a Docker compose file. So the compose branch is the outcome of what we are going to learn today, and main branch that you see here, assume this is shared by the developer who just has understanding of how to write source code for the MERN stack application. Now let's move to the whiteboard and let me explain what exactly is this MERN stack. So before this, you need to have understanding of what exactly is a three-tier architecture application. So it's very simple. A three-tier architecture application is an end-to-end application which has tier 1, which is presentation layer. In simple words, you can also call it as UI or the front end tier. Then there is second tier, which is called as the business logic tier. You can also call it as server or backend. And then you have a data tier, which is nothing but your database. So any three-tier architecture application has these three tiers. For example, if you take Amazon.com, which is a e-commerce application, it is also a three-tier architecture application where as a user, you are interacting with the UI of Amazon, which is the front end of the Amazon, which might be written in React.js or anything. And let's say through the UI, you are entering your username and password, or you are selecting a product. Immediately, the instruction from the UI is sent to a logic layer or the backend application, probably written in Java, Python, or let's say any other programming languages. I'm not talking about MERN stack yet, where logic is executed. For example, you have entered the username and password, or let's say you have selected a product. So the product details have to be shown, right, on the UI. So the instructions which are received by the UI are sent to this logic layer, where the logic layer talks to the database. So if the user is asking for the details of a product from the UI, so the instructions are sent to the logic layer, and in the logic layer, a connection is implemented with the database, and from the database, the details are fetched by the logic layer, where user is asking about a product name, the age of the product, cost of the product, and from the logic layer, again the details are sent back to the UI. So this is how any three-tier architecture works. So the front end receives the instructions or something that the user can see. The instructions are sent to the logic layer, where some kind of processing takes place. And this processing, if required, communicates with the database to fetch the product details, employee details, or to insert anything into the database. And if required, again, database can, or in the logic layer, information from the database is received and finally displayed on the UI to the user. Now there are multiple architectures for the three-tier application, and these days, from last, let's say, 3 to 4 years, MERN stack has become a popular choice. Now, what exactly is this MERN stack? So in the MERN stack, M means MongoDB, which is a database. Then you have E, which is Express. Then you have R, which is React, React.js. And then you have N, which is Node.js. So when you write a three-tier architecture application by using all of these, then that means you are using MERN stack. There is reason why a combination of this has become popular. Before explaining that, let me explain which is front end, which is back end, and which is database. So quite obviously, you might be knowing here MongoDB is the database layer. So in your three-tier architecture application using MERN stack, MongoDB becomes your data layer. On top of it, the backend application or the logic part is written using Express.js. And whenever you have a backend, let's say you are writing application in Java or Python, you need a server to deploy your backend. In MERN stack, that is taken care by Node.js. So the combination of Express and Node, where you are writing the logic in the Express and deploying that in the Node.js. This becomes your business logic layer or the backend layer. And on top of that, you have the presentation layer, which is written in React. So M, E, R, and N for the Node.js together is called as MERN stack application. Right? Now the question can be, but Abhishek, why has this become very popular? The first reason is that the open source, like you can use all of them completely free. So if you are a student, if you are not a working employee, right, you can access all of them completely for free. Of course, they have enterprise versions as well. For example, MongoDB has a enterprise service offering. But if you want to write these applications as a student, as a startup, or as a non-working employee, all of them are open source. So it is quite easy. So the learning curve is straightforward. Second thing is it's a JavaScript framework. So if you watch carefully, you have React, you have Node.js, you have Express.js. So there is a homogeneous kind of thing. Or if you are aware of JavaScript, it is quite easy for you to learn Express.js, React, as well as Node.js. So somewhere or the other, all of them belong to the same family. And third, the simplicity. Also the security aspect, but I will not deep dive into the security aspect in this video. But also because of the simplicity of the programming languages that you see here, it becomes easy for anyone to get started with the MERN stack. So let's do a quick code walkthrough. To do a code walkthrough, it is easy if we have an IDE. I don't know how many of you are aware on the github.com. If you just click on the dot, so you will get an integrated IDE environment. So let me use that to do the code walkthrough. So this application has a backend folder and a front-end folder. If you are wondering why there is no DB folder, because database is deployed directly through the backend, we will establish connection with the deployed database. So that's why within the DB folder, there is a file for database, which is connection.js. And this file is responsible for establishing connection with the database. So you can see connection string here. You can also read this connection string from the environment variable or from the config file. I will also show that in the video when we deploy it using Docker Compose. For now, I know my MongoDB container name is MongoDB. So I am using that in the connection string. So MongoDB, you can download it directly or run it as container. It is easy to run as a container. So we will use that, and the name of the container will be MongoDB. And like this is how connection is established. And then we have a try block where I'm just verifying if the connection is successful. If the connection is established successfully, we will have a message which is stating you are successfully connected to the MongoDB. And in the backend, there is another important file, which is server.js. So server.js, we will implement CORS. CORS is cross origin resource sharing. Especially if you are a developer, you need to focus on this particular thing, cross origin resource sharing. I have seen a lot of examples of the MERN stack application on GitHub, but practically when I tried to containerize those applications on GitHub, none of them were working because of the CORS issue and because of the database connection issue. So I happen to write this application taking reference of official MongoDB example. So make sure you understand the CORS part if you are a developer. So I have implemented CORS, and I have also provided on the context path, which is /record, and on which port is the application listening. So port I have taken 5050 as default, or if user wants to pass any port from the environment variable. So the default will be 5050. And in the backend, another important folder that you have to look at is the routes folder. Because in the routes folder, you will define what all APIs are supported. You can see, you can implement get on the application, which will get the employee records, or you can get a particular employee record using this particular API, or you can post where you can submit a employee record as well on this particular context path. Similarly, you can update and you can also delete the employee records. So these are the things that you mention in the record.js, which is the core logic of your application. So a connection string or a connection file, which is establishing connection with the database, and then your business logic and also catching exceptions for failures in your business logic. And finally, a server.js, which is implementing the CORS as well as the port on which your application is running. You also have front end, And in the front end, there are a lot of things like we are using Cypress, there is Tailwind configuration. But if you want to look at the important part, go to the components, and within the components, you have record file and the record list file. So this is where front end is talking to the backend. If you just spend some time going through the assets file, the configuration file, HTML files that we have used here, you will understand how the front end is established. But the more focus is towards backend as well as the database. Perfect. So this is the quick code walkthrough. Now let's proceed with containerizing this MERN stack application. So again, I'll change the URL back to github.com. So let me pull my Visual Studio Code. So I have already cloned the application in the VS Code, and I can also just verify on which branch I am on. So it says I'm on the main branch. Perfect. So in the backend, there is no Docker file, and also in the front end, there is no Docker file. So we can get started by writing the Docker file. We will start with front end. Especially for MERN stack applications, writing Docker file is very, very simple. All that you need is this particular instructions from the developer. So developer has provided. If you switch to the client directory, just run npm install and npm run dev. So npm install will install all the dependencies, and npm run dev will run the application. Perfect. So I will start with official node image. So I will take node official image. You might ask, but Abhishek, why not Ubuntu or why not UBI? You can also use that, but the official node image will come with direct npm installation. It will have out of the box. So you don't have to bother again installing those dependencies in the image. If you are using Ubuntu, again, you have to go and probably you have to run command like run, figure out what is the command, something like apt install npm, something like that. Instead, if you use the base node image itself, it will have npm. And another good practice is never use latest. Always pin to a particular version. Because if you are pinning it to latest, 10 days later, the latest version might change. And 10 days later, if you are executing this Docker file, there can be errors. So it might work in your local environment, but when you take it to staging or production, it might fail. So that's why you need to pin with a particular version. And every time you start writing a Docker file, make sure you have a working directory. So I will select app as the working directory. What does a work directory do? Everything that you are going to do hereafter are going to be implemented on the app folder. That's it. So before running npm install, what you will do is you will copy the package.json, because how will npm install understand what are the dependencies, what all it should download? Just like if you're working in Python, working with Python, it is equivalent to requirements.txt file. If you're working in Java, it is equivalent to pom.xml. If you're working with Golang, it is equivalent to go.mod, right? So copy package.json. You can just say to the dot, that is the work directory folder, and just run npm install. So now all the dependencies are installed. Then we will copy the complete source code, right? The complete source code for the front end is copied. Then before running the npm run dev, which is provided by the developer, what we will do is we will expose the port 5173. I believe it is correct. We can also check it here. Yeah, 5173 is the port that I want to expose, because my application will run on that particular port. Finally, I can use CMD or entry point, and all that I have to do is I have to take the instructions npm run dev. So npm run dev. What happens when you run this command is, for the purpose of your understanding, so npm run dev in the front end, it will go to this file, config file, not this one, my bad. So if you look at the src, in the, there is one file, yeah, sorry, it will go to the package.json, and in the package.json, in the scripts, you have this dev. So this particular command is executed, right? So make sure you have the dev script in place when you are running npm run dev. If you are running npm run build, this command is executed. If you are running npm run lint, this command is executed. So this is how the npm command works. The configuration is taken from package.json. Perfect. I believe our Docker file is ready. Let me take my terminal for the purpose of easy reference. I will move to the MERN folder. I will move to the client folder, front end. And this is the Docker file that we have just written, right? So here I will try to run the command docker build MERN frontend one dot, or anything that you want to put. Let me put it as just MERN frontend. Okay. Now, if our Docker file is right, it will build the image. Okay. Docker is not running. I'm using Docker desktop. So I'll just run the Docker desktop. Yeah, you should make sure that your Docker is running before you build the Docker image or before you run it. Okay, let me verify if my Docker is running again. Docker, I can just do PS. Okay, it's coming up. Let's just wait. Yeah, I think it is up now. If I just do Docker PS one more time, perfect. So my Docker is up and running. Now let's give the command one more time to build the front end. Now your question can be, Abhishek, why are you building this? Can we directly use Docker Compose? No. Docker Compose needs your Docker files, right? Instead of executing these instructions one by one, which for the purpose of practice we are doing, or for the purpose of understanding. So all these instructions, the build instruction, the network creation instruction, the running instruction, they can be put in one file that is called as Docker Compose. I will explain that again in a while, but you need to know all of these things even if you're using Docker Compose. Okay, now this is built successfully, but I want to also run it and see on my local machine if the front end component at least is built fine and running. What I'm going to do is I'm going to create a network, Docker network create, let's call it as something like demo or MERN. Now you might be wondering, but Abhishek, why is a network required? Network is required because when you have multiple containers, we have front end, we have back end, we have database. So if you have a common network, and if you can use the common network for all your Docker containers, they can communicate easily. So let me explain that as well through the whiteboard. Whenever you are creating a Docker container, right, on your host, so your host has a different network and your container has a different network. You can use a bridge to connect your host to your host. But what if you have multiple containers? Every time you can create a bridge to connect to your host and to run your application on your local host. But it is easy if you have a common network between your containers so that your front end can communicate with your backend. Your backend can communicate with your database, just like how Kubernetes also does. There is a common network within your Kubernetes, right? Similarly, it is good to have a common network when you are running three-tier architecture application or multiple services using Docker Compose. So it says a network called MERN already exists. That's fine. So now I will run this container. Docker run. I will provide the name as frontend and the network that we just created. Let me call it as MERN. I'm doing the port binding 5173 to 5173 on the host so that I can access it. And the name of the image is MERN frontend. Don't worry, all these instructions are available in the compose branch. Okay, it says that my container is running. I can also look at the logs of the container. Docker logs frontend. Okay, it is saying, yes, Abhishek, your frontend container is running. Now let me take a terminal. Localhost colon 5173. Okay, it's coming up. Perfect. I have the front end. But in the front end, now if I try to provide some details, I'll say Abhishek.Veeramalla, principal software engineer, a senior resource. And when I click on save employee record, nothing will happen, right? If you see Docker PS, I just have the front end container, right? I can also see this using F12, the developer console, right? Now, if I click on save employee record, see, there are a lot of errors because you don't have the backend application itself, right? If you don't have the backend application, quite obviously, you need to build the backend. And before that, you need to run the database using a container. Always make sure you run the database first, because if you look at the source code, backend, as soon as it is started, it will try to connect to the database. And if the database does not exist, the connection will fail and your backend will fail. So that's why always start the Docker container for database first. That is our MongoDB. So let me take my terminal. Perfect. So I will run the MongoDB now. So Docker, I already have the MongoDB command. You can also take it from the compose branch, and you can change the MongoDB version simply to MongoDB colon a particular version, or I'm using latest now instead of just going and referencing the latest version. But it is always a good practice to use a particular version instead of latest. Okay, I'm also mounting one folder in my local to the MongoDB data DB folder, because a database needs to store the data. So it needs a volume, right? So I'm bounding my local volume or a folder in my local to the MongoDB. Just like how we did for the front end, I'm also binding 27017, which is the MongoDB port, and network, I will use MERN. It said unable to find MongoDB locally. So okay, there is some permission issue. Probably this image called MongoDB latest does not exist. Let me check for that. What should be the image? Okay, it is Mongo latest. My bad. Okay, perfect. Now Mongo is also running. You can also verify that. Just take a terminal, localhost 27017. MongoDB is running. It says it looks like you are trying to access MongoDB through the HTTP protocol, which is not right. But I want to verify it is running. Now it's my turn for the backend. Again, for the backend, we need Visual Studio Code. We need to write the Docker file. So new file, Docker file. All this is already available in the compose branch. I'm repeating again. So while watching the video, or if you want to implement it later point of time, just refer compose branch. Because all of them belong to the JavaScript family, front-end Docker file and back-end Docker file might look very, very similar from Node 18.9.1, which I used for the front end as well. Because end of the day, this is also built using NPM. That's the advantage of MERN stack. It is very, very simple. If you go to the README file, client, we are running npm install and npm run dev. And similarly, for the backend as well, we are running npm install and the command has changed, that is npm start. Cool. So this is done. What should be the next step? Work directory. We will use app as the work directory. Again, we will copy the package.json. Same command. So if you write front end file for MERN stack, you already know how to write the backend for MERN stack. Okay. Then quite obviously npm install. Then we will copy the complete source code. Then we will expose the port. But in this case, port is 5050. Finally, in the CMD, I will just write npm start. That's it. My Docker file is done. Now, let me go to the terminal. CD to the backend. Make sure you switch directly to the backend. And run Docker build, this time backend. So let me say this as backend dot. So build is successful. In your case, this might take time because you will be doing it for the first time. I have done it previously also. So all the npm related dependencies are already on my machine. I mean, there are some layers of the Docker already. So that's why it is taking less time. Okay. Now let's run it. Docker run. Okay. This is for the backend. Docker run ---- network MERN. If you are missing the network, your connection might fail. Front end might not be able to communicate with the backend because your containers have to be in the same network. If you want to understand more about Docker networking, I did a complete video. Please try to watch it. I have explained what is overlay network, what is the bridge network, what is the host network, and how do they work. So watch that video if you want to learn the details. Docker run, I have provided the network. Name, I will put just as backend. Port mapping is good. Finally, the image is MERN backend. Okay, it said this is also running. Let's see. If I go to just 5050. Yes, it is working fine. It said cannot get. That means backend is receiving our request. Now let's see if frontend can communicate with backend and backend can communicate with database. Create employee. Again, I will do the same. Abhishek.Veeramalla, principal software engineer, senior resource, save record. See, you can see the record here. And literally, I can edit the record. I can say senior principal software engineer. and I can save the record, or I can delete the record. That means front end is talking to backend and backend is also communicating to database. If you open your developer debugging console, right? And if you try to execute these actions, you can see the workflow as well. Now let me provide the details. Senior, and as soon as I click on save employee record, you can see how the requests are flowing from the front end to the back end and to the database. So you can take a look at it here. Perfect. So now we have containerized the MERN stack application. We have written the Docker files, we have run the DB locally, and we were able to verify the connection between the containers is also fine. Points to note here. Even if you are explaining to the interviewer, make sure you explain the first step as create network. If you don't do this, it is difficult for containers because, as I explained, you have this virtual machine or your laptop, and your laptop has a network, let's say each0. And when you run a container, even within the container, it will have a network, right? The container also has a network. So when you are trying to access the container on your machine, there has to be a bridge. So by default, Docker comes with a network, a default bridge network, using which you can connect the container with the virtual machine or your laptop. So container to host networking is fine. You can use the bridge networking or you can use the host networking. But what if you need a secure network that can only be accessible between your containers? Nobody else can access that network. Or let's say if your container has to communicate to the other one, right? They need to know each other. For that, we will create a common network, a bridge network. And whenever we are starting this container, and this container, we will bind that network to the containers so that they can easily talk to each other. And then second step can be your Docker file creation for the front end. Third step is to start the database. And even in the database, you should be explaining about the volume that you have mounted. And finally, the backend. Okay. So first step is the network. Second step is you have started the services. And along with the services, you have also mounted the volume for the database. Now, Abhishek, we have run these many commands. Instead of running all these commands, can I do it in one shot? Yes, definitely. And that is where Docker Compose comes into picture. In a nutshell, what is Docker Compose? Instead of executing multiple instructions, such as your network creation, starting your service 1 container, service 2 container, service 3 container, and even while starting the containers, I have explained you that there is a dependency. First, you need to start the DB container. Only then you have to start the backend container. So you have a particular order and you have multiple steps. So to avoid all of these, the manual activity, you can write a single YAML file, and that file is called as Docker Compose. So Docker Compose is used to run multiple containers, making sure the container's dependency is taken care, and if required, a common networking can also be provided for the containers. This is how Docker Compose works. Now, what I will do, I will delete all the containers that are running. Docker rm, let me delete container this, and this. So I have removed all the containers. You can also remove the containers using these names. Cool. Docker ps, nothing is running. And even if I go to my application, it's not running. I have executed almost 10 instructions before. Now I will just write one Docker Compose file and I will only run that Docker Compose command. And my goal is to make sure all the containers are running with networking and the volume. So go back to my Visual Studio Code and at the root level, okay, at the root level, I will create a file. Let me call this file as docker compose.yaml. Perfect. Now, how do I write the Docker Compose file? Syntax for Docker Compose is very simple. You just need to remember what are the steps that are required to run the containers, right? And in the YAML file, assume this is compose YAML file, you have 2 to 3 main pieces. First is the services section. So you will create a services object, and within that, you will just write what are the different services that you have. For example, front end, and just write the front end specification. Back end, and just write the back end specification. DB, and just write the DB specification. And within the backend, you can write something like depends on DB. That means this particular block will only be executed once the DB block is done. Now the services is done. You have network. Network is executed first even before the services, right? So you will write the network block. And finally, you will write the volume block, right? The driver block. Which kind of volume you want to use? Do you want to use a local volume or any other volumes? That's it. This is Docker Compose file. If you know these things in the interview, if you explain that there is one services block, there is a network block, and there is a volume block, where in the services, you will define different container configuration that you have, how to start the container, where is the Docker file, what is the port binding, right? If you can explain that, similarly for the backend and for the DB, you know how to write a Docker Compose file. So I will start with services. Like I said, in the services, what are the different services that we have? So this is one example that is given by Copilot. In our case, I have front end. Where is the front end Docker file? It's in the folder MERN front end, right? What is the port binding that I have to do? 5173 to 5173. Do I require any volume? No. Is there any dependency? No, there is no dependency, right? So the front end container part is done. Now we will move to the backend. Again, don't worry. If you go to our GitHub repository and if you switch to the Compose branch, there is already a Docker Compose file. So you can see here for the front end, for the backend, for the MongoDB, for network, as well as volume. Of course, one thing that I missed is I need to provide that there is a common network, right? What is the network? MERN. Abhishek, I did not create network. Yes, you need to create the network. So networks, right? So this is the syntax. It will create a network for you with the name MERN, and the type of the network is the bridge network. If your type of network is host, change it. If your type of network is overlay, you can also change it. Now let's create for the backend. Backend, you need to provide image if you are running the image directly, but I don't want to run the image directly. I want to build it from the scratch, right? Because I have the source code with me. So MERN backend, This is the folder where the Docker file is available. I will skip the environment section for now. It is only required if you want to pass environment variable for connection string or something. Ports 5050 to 5050. Then you have network. In the networks, you have MERN, which is the network that I want to use, right? So then, like I mentioned, depends on Mongo. What is this Mongo? This is the database stage that I'm going to write. If you change this name, you need to change the name here, right? If you want to put it as DB, make sure you put DB here. In the Mongo, what you will notice is I am using image directly. Okay. In case of Mongo, I am using image directly, but not the Docker file because I am running MongoDB database directly. I'm not using the Docker file. So Mongo latest or any specific version. Use version, preferably use version. Port binding 27070, right? MERN, perfect. I don't need environment variables or the auth configuration because by default, when you're starting MongoDB for this simple application, there is no auth configuration. And database, where do you want to have it? Sorry, the volume mount, which one do you want to have, right? So I can create a particular folder like this, Mongo data, and I can just put that it needs to be mounted to the DB folder of the Mongo container. Finally, the volume section. In the volume section, you just need to mention what is this Mongo data, right? So the Mongo data is from the driver local, Mongo data, and I will provide the driver as local, driver local. That means to use the host machine. Perfect. I think our Docker Compose file is done. All looks good. Because I don't have containers running also, let me try it. The only command that you need is Docker Compose up. Let's run it as background, right? So when you are running -d, then your containers, just like it is equivalent to Docker run -d, where they will run in the detached mode. So Docker Compose is executing. See, it is starting. It has created the network for us. Then network creation is successful. It has created this container, the second one, and the third one. Perfect. So it has taken the instructions that we have provided and executed these containers. Right? Everything that we have provided here. Now let's see Docker PS. Cool. All the containers are running. Let's go back. Execute it. Let's create Abhishek.Veeramalla principal, same thing. And let's try to save the record. Perfect. Let's edit it. Senior looks good. So edited senior principal software engineer, and I can also delete the record. So this is how using Docker Compose, you can simplify the steps to run the containers. And imagine when you have even more number of containers, when you have complicated networking, when you have too many volumes. So Docker Compose can help you a lot. Thank you so much for watching today's video. Make sure you look at the Compose branch if you run into any issues, right? So instead of looking at the main branch, take a look at the Compose branch, because I have already written the Docker files, docker compose.yaml, and even there are some changes to the source code. So if you are trying to run them as containers, if you want to use Docker Compose, so refer to the Compose branch. Thank you so much once again. See you all in the next video. Take care. Bye bye.